Welcome everyone. In this video lecture, we will solve a very simple GATE 1999 question which is based on properties of negative feedback. So in this question, we have to simply say the amplifier negative feedback properties. So which are the question is how our question is negative feedback in an amplifier. Option A reduces gain. Option B increasing frequency and phase distortion. Option C reduced bandwidth. Option D increased increases noise. So this is a very simple one. So everyone can say that the answer will be our in negative feedback. It will reduces the gain. Okay. So this one is the right answer. But apart from that, we will now discuss some important relevant properties of negative feedback. Okay. So the properties I am just writing here. Properties of negative feedback. For more detail, you can also follow that book, Cedar Smith, Microelectronic Circuit, which is a very good book. So from that book, I am taking this theory portion. So the very first property, we can say the first property of any feedback circuit is our gain desensitivity. Gain desensitivity. So gain desensitivity, what it exactly mean that I am going to discuss. So for example, suppose if we have a amplifier having amplifier gain 10 to the power 4, and for example the I'm just the feedback gain I am saying 0.1. Okay, so this one is the amplifier gain and beta gain, and if we are saying the amplifier gain is reduced by 20%, so the new gain will be around 0.8 into 10 to the power 4. Initially it is 10 to the power 4, 1 into 10 to the power 4. Now 20% reduction means 0.8. Okay, and this one is beta. Same, I am just taking. So the overall gain, so the percentage change in overall gain, if you we have to find the percentage change in the overall gain, it is denoted by the formula del AF by AF. For more detail, you can also go through my video. I will put the video of this particular gain desensitivity thing in our video that I will put in our description link. So DAF equals to DA by A into 1 by 1 plus beta A. So this one is basically the formula for the gain desensitivity. Why I am just doing this one. And for more detail, I already told you go for the Cedra and Smith book. I am once again writing. I will also share my video. Okay, book is Microelectronic Circuit. Microelectronics circuits. Okay. So if I am saying what is the percentage change in the feedback gain. So percentage change in feedback gain we have to write, so del A by A, so it is changed by 20%, so better to write this one is the percentage change in AF. Once again I am writing this one is nothing but simply we can say this one, we are saying percentage change in AF, and this del A by del A is the percentage change in A. So we have to find this percentage change in AF. So 20% into, okay, I'm taking the blue one, into 1. 1 plus beta is our 0.1 into A. So our new A, it will be 0.8 into 10 to the power 4. So if we solve, it will come nearly 0.025%. So from here we can observe that even if there is a change in amplifier gain, means this one is the feedback structure. I think everyone knows, but I am still making. If the A and some feedback amplifier is there, beta, some feedback kind of thing is there. Okay. So this say V naught and say Vs. So feedback gain V naught by Vs is the feedback gain, which is 1 by A by 1 plus A beta. So in this case, what we can observe that the value of the feedback gain percentage change, we require the percentage change in the feedback gain. So this percentage change del f by af can be written as del a by a into 1 by a beta. So it is very less. So we can say this one is the property, the first property which are saying gain desensitivity, means that is make the value of the gain less sensitivity towards the variation in the circuit parameter. So the overall circuit is very less dependent on the amplifier gain. Okay. So this one is the first property, say the gain desensitivity, because our gain part is very much stable even if there is a change in a. Okay. So as we seen there from this example, if the a is changed by 20%, the change in the change in the overall amplifier gain is 0.025%. I will share this video for this gain desensitivity. Now next one, property. These are the very famous property that we have to know. That's why I am just writing all the properties. Number two, bandwidth extension. Bandwidth extension. And I am just writing in a brief. So for more detail, you can follow from book also. So for bandwidth extension, so for this one, I am just drawing a graph for you. So it will much easier for you people to know the what is the knowledge behind this. Okay. So if this one is somehow, I am saying the amplifier gain. Okay. So this one is the amplifier gain. So if we this axis, the vertical is our gain, and this one for the frequency. So if for the negative feedback, if we plot, it will come like this. It will be overlapped on this one. Okay. Okay. So this one is the what we can say the extension. Initially the bandwidth is more or less this one. Okay. This one is the bandwidth initially. Okay. But for amplifier, but when this one is our af, when for the negative feedback, the bandwidth will be more or less increase. So from this section, as a brief, we can say bandwidth of feedback 1 will be greater than bandwidth of the A. So this one is also very important. So we have to, so for all detail, I will share this also link. But for these are the simple properties. So gain desensitivity is one of the property. Bandwidth extension is another property of a negative feedback. Now I am going to write the third property, that is our interference reduction. So now you remember these 3 4 points: interference reduction is one more property, and now next one we can say reduction in nonlinear distortion. Reduction in And the last one, we can say control of input and output resistance or impedance. Control of input, output, impedance. So basically, these are the very important one. So you have to remember the formula for the gain desensitivity and for the bandwidth extension. And for more detail, you can go through that particular book of Seda Smith. So this is all about this video. So the question is very easy. What should be the negative feedback in an amplifier? So it will reduces the gain. But few properties that we have to know, that are our gain desensitivity means gain of the overall feedback circuit, negative feedback circuit, is somehow stable even if there is a change in the particular component value. Bandwidth extension, we can extend the bandwidth through negative feedback. We can reduce the nonlinear distortion, reduction in the noise also, and control of input output impedance. So this is all about this video. So thank you for watching this video.